Thomson is an electromechanical clutch and brake manufacturer. We have an advantage in a certain niche of speed and inertial loads that financially gives our customers a superior benefit in their machine building.
What this is a test fixture that simulate applications that customers use this product in the field. This system could be a punch press, it could be a cut-off knife, feeding labels into a machine. Back here you'll see there's a servo motor, there's an inertial weight which is simulating similar loads for the wrap spring. Then you can see the visual, there's just hardly any visual difference between the two products.
If you're on a pick-and-place robotic machine and you need to move at 15 to 20,000 RPM, that is an absolute application for a servo system. However, if you're a hole punching machine, or you're a banding machine or a packaging machine, and most of the time you're in that 500 RPM or 750 RPM range, a wrap spring is a more elegant solution. It's more cost effective, of course, and technologically it's on par with the servo drive system. I think the best way to look at it is the complexity of the servo drive system and the cost associated with that servo drive system is far more difficult to add value to your application. If you have a machine that sells for $10,000 and you're installing a $3,500 servo system, it's going to make it very difficult for you to compete in the marketplace. Whereby if you have an electromechanical wrap spring application doing the same function, you'll be looking at a cost probably more in the $500 to $650 range.
What we have here, this is the wrap spring scope trace, and this is the servo scope trace. Basically, as you look at both of the screens, you can see the angular accelerations, the time to speeds, the rated RPM, and the braking time were pretty much similar. The wrap spring can do the same functions as the servo.
The wrap spring clutch and brake are designed for lower speeds, from 250 pound-inches up to over 5,000 pound-inches. And there's different frame sizes. And again, they have different speeds, capabilities associated with them. The servo system, as I mentioned earlier on, the cost factor is nearly 6 to 7 times more than the wrap spring would be.
With using the servo, of course you need the motor. Then to make the motor operate, you need the power supply and you need the driver, which is our additional cost in addition to the servo itself.
For servicing the item down the road, if anything went wrong in the field, all right, with your machine, it would be very simple to send replacement parts if it were a wrap spring application, and to train your customer to repair the machine. If it is a servo system, most of your customers will not have that sort of level of capability to repair them. And the cost associated with that is extremely high compared to a wrap spring application. If you look at your total installed cost for a servo system versus an electromechanical wrap spring, you're looking at approximately 6 to 7 times just for the hardware for the installation base. Our expertise and experience in applications has given our customers, I believe, the value that they need to grow their business. It's our job to introduce the technologies, all right, to the marketplace to enable them to make a rational decision for their business of whether or not a wrap spring is better suited for that specific application versus the servo drive systems.